So last time we established a really good mechanism to show the relationship between IR light and molecules that can absorb that IR light to vibrate more and to therefore heat up. But we left with this question of like, well, does this actually happen? Are there data to show that this is happening and that this is a problem? And so let's take a look. So this is all data from NOAA, the National Oceanic and Atmospheric Association. They have a carbon dioxide concentration measurement facility at Mauna Loa. And you'll see that these concentrations are measured in parts per million. Let's just recall real quick. Parts per million is equal to 1 unit per 1 million unit. So if we have 1 ppm, then that would be equal to 1 carbon dioxide mass unit, let's just call it a gram, per 1 million, I'm going to call it 1 times 10 to the 6th grams of all gases that are present. So back in the 1960s, our average carbon dioxide concentration was less than 320 ppm. Okay, so these red lines keep track of the two measurements of carbon dioxide that it takes at 2 different times of the year. When we're at higher concentration, then that's usually the summertime, and then if it's lower, then that's usually the winter time. Okay, and so then the black line is basically like the average between the highs and the lows that naturally occur every single year. Okay, and so you can see that there has been an upward trend from the 1960s all the way up to basically this year, which makes a lot of sense given the fact that the economy has been continuing to ramp up, and so a lot of what they call anthropogenic activity, which is basically activity by humans, has been increasing as well, right? We're doing more business, probably because we're burning more fossil fuels. We've also made a lot more babies in this time, right? And so all of those babies need to be heated and all of that, okay? So that's just the carbon dioxide data. Now, again, this carbon dioxide data was recorded by NOAA, which is a government scientific entity. Now down here, this graph is on temperature anomaly, okay? And so this is just a graph of how temperatures have changed in the last about 150 years, okay? You can also see that there's been like, I don't know, there was like a dip down here around 1910, and then there was a spike around 1940, and then there's been a gradual increase up until 2020. What we really want to do is we want to see if there could be a correlation between how much carbon dioxide has been added to our atmosphere versus how the global average temperature has changed over the last few years. So I stretched these out so that these two graphs can roughly trend with each other from the 1960s all the way up until present day. And you can see that the trend is pretty darn similar, right? So they are both upward trends. Now their slopes are not exactly the same. There's got to be like some sort of way that we can relate the slope of one to the slope of the other. But you can see that from 1960 to now, it's pretty tough to deny that there would be a relationship between increasing the carbon dioxide and increasing the temperature. Now you might say, aren't you committing a confusing correlation with causation? I would say yes, except that I gave you a mechanism in the part 3 video. These two sets of data are not just correlated. I've explained exactly how one of them causes the other, specifically how this increase in carbon dioxide levels causes this increase in temperature. I gave you a mechanism. In other words, I gave you a scientific explanation. And so no, I am not committing a fallacy by having you conclude this, as I've done all that I can in my power to make my claim as scientific as possible. At this point, most people should be asking themselves, well, why do I even care that global warming is even happening? I'm not going to personally answer that. But I will direct you to watch Before the Flood, which is a documentary that was released by National Geographic back in 2016. And it is not available on YouTube, but it is available on our Blackboard page. It's a Kaltura media element. So I can't link it here in this YouTube video, but it will appear right below this embedded video on our Blackboard page. So please give that a watch. You don't have to watch it this week, but I would like you to watch it sometime between now and the end of the semester. So to move our discussion forward, though, once you care that global warming is happening and how it is affecting our world and the people that live in our world, now you should be asking, well, where is the carbon dioxide coming from, and what can I do to reduce how much carbon dioxide is getting into the atmosphere? So let's take a look. So here's the global carbon cycle, okay? So what we usually see, so if people weren't an issue, we would naturally be seeing that, vegetation and land gives off a certain amount of carbon dioxide, but the vegetation also takes up a certain amount of carbon dioxide. We also see the same off-gassing and in-gassing with marine wildlife as well. That's both ocean, like animal critters, as well as oceanic plant life. If you just consider this and this, then overall there should be a pretty good balance of carbon dioxide uptake and carbon dioxide intake, okay? But once you take into account all of the industrial and other modern practices that give off carbon dioxide, then you suddenly start to have an additional amount of carbon dioxide that is only put into the atmosphere without there being any additional uptake as a result. Now that we've also been seeing some increasing global temperatures, we're also starting to see that as the polar ice caps melt, there has been additional carbon dioxide and methane that gets released out of those ice reserves, okay? And so that's not exactly an industrial sort of process. It's a natural process, but it's resulting from this unnatural and unexpected increase in global average temperature. And it's going to take, a very steep drop in global average temperature for that methane and carbon dioxide to get reincorporated into any additional snowpacks and ice caps, okay? So since what we can do about things at this point has to do with those human-based or also called anthropogenic activities, let's focus on that, okay? So in 2014, this was where all of the global carbon dioxide emissions from fossil fuel combustion and industrial processes were coming from. What you can see is that China is responsible for 30%, or at least they were in 2014, and the United States was responsible for 15%. So at first you're like, ooh, China's the bad guy. But if you consider China's population versus the United States population, per person, they're only responsible for 6.6 metric tons. Versus in the United States, we are responsible for 15.5 metric tons of CO2 emissions per person. So we have a smaller percentage overall, but more of it is coming from us, on a per person basis. This data suggests that the average American lifestyle results in more greenhouse gas emissions than the average Chinese lifestyle. So if Americans want to reduce our carbon footprint globally, we need to focus on making those changes in our domestic lifestyle and also how we do business domestically. So then we look at United States greenhouse gas emissions by economic sector. Again, this data is a little bit outdated, but it's pretty close for right now. And you can see that most of it is coming from just electricity, and then the next greatest proportion is from transportation. And then the next greatest is industry, and then there's only 12% additional greenhouse gas emissions that are coming from commercial and residential use, and then there's only 9% that comes from agricultural use, okay? But if we push forward and we look at where that 29% of electricity is coming from in each of these subsectors here, we see that residential and commercial entities are responsible for now 33% of all greenhouse gas emissions, right? So when you factor in all of the energy, all of the electricity that goes into residential and commercial processes, then not only is there this like 12% due to like, you know, heating and cooking and all of that, but a lot of electricity is being utilized by, you know, people in the homes and people with small businesses. Industrial uses start using more electricity as well. Transportation still hangs out at about 27%, and then agriculture climbs up just a little bit to, actually, not really at all. There you go. Okay. So then this leads us to conclude as well that, okay, of the electricity, like residential and commercial entities bear a lot of the burden, right? And then there's also additional transportation. Given how much transportation happens because of, you know, commuting as well as shipping and things like that, then that leads me to believe that if we were to factor this into these other processes, these other sectors as well, residential and commercial entities could also bear a pretty big proportion of the burden of greenhouse gas emissions as well. But we won't talk about that too much. But anyway, these data traditionally urge us to think about what we as individuals can do to change our lifestyles to reduce global greenhouse gas emissions so that we're not experiencing as much global warming. Before we move forward, I would like to say that in recent years, there's been a big social movement to treat residential and commercial entities separately, and even to treat citizens separately based on their income level. What am I really saying here? I'm basically saying that it's coming to light that businesses and the very, very rich, and I'm talking like multi-millionaires and billionaires, they live a much more excessive lifestyle than at least 85% of the rest of the population. And I would even hazard to say 95% of the population. I'm talking people with income levels like you or me, okay? Therefore, these rich entities and these businesses would be much more responsible for this 33% of greenhouse gas emissions from, quote, residential and commercial entities than the rest of us would be, okay? So personally, I would like to see this data, or at least this 33% slice, sliced down even further so that we can see whether or not folks like you or I are responsible for that much of the greenhouse gas emissions let out by Americans each year, or if we're not. Okay, but until we get that breakdown of this data, nonetheless, it's also nice to consider what you and I can do in the meantime to control this outcome, okay? So let's move forward to the next slide where we're going to consider what we can do to reduce carbon dioxide emissions. Here are things that you can do. So of course, number one is just like limit how much electricity and gas you're using. Efficiency is another thing. It's also a good idea to limit your personal transportation, right? So instead of driving yourself, maybe you and 3 other people who all work together could drive the same car there, right? And then that's fewer people using the same resources. Okay. If you can utilize zero or low emissions transportation, like buses and electric trains and bicycles, or even walking on foot, that's of course a good idea. Okay, so then we get into a little bit more like of the nitty-gritty things about lifestyle that have started to become more popular discussion topics lately. Okay, so this one about limiting the use of products that had to travel a long way to get here. Basically, we're looking at imported goods versus goods that were entirely grown and manufactured domestically. It makes sense that if you had the choice between a tomato that was grown in Mexico versus a tomato that was grown in your backyard, there are fewer carbon dioxide emissions associated with the tomato that you grew in your home than there are with the one that was grown in Mexico. Granted, probably the one that was grown in Mexico is more convenient for you to obtain. It's a little bit more pricey, but it is more convenient for you to obtain because you don't have to have the resources of a backyard and soil and water and seeds and sunlight to grow that tomato, right? So that's why people often get their produce from the grocery store instead of trying to grow it for themselves these days. But the greener option would be to return to backyard gardening or even patio gardening in containers. And then, of course, the same thing goes for even non-produce items like clothing, even fabric. I mean, if we had more fabric manufacturing factories, that fabric would only have to be shipped across the United States instead of shipped all the way from, the Asian Pacific. Right? So again, if we can limit how much industrial transportation is happening, then that's actually going to be better for the environment. It's also a good idea to limit your animal product consumption because there's additional food that has to be grown and given to animals, right? So that's one reason. So that would help us eliminate some of the transportation associated with agriculture. But one of the other basic facts is that beef especially, so cows, emit a ton of methane in their natural life cycle. Methane, CH4, is an even better or worse, I guess, depending on how you view it. But methane is even more efficient at turning infrared light into heat. It does so in exactly the same ways that water and carbon dioxide do. So methane does that even more. There's an even greater increase in temperature when methane absorbs IR light. Okay, so if we can eliminate how many cows we're growing that just naturally fart, then that can help us reduce how much methane is in the atmosphere and therefore help us reduce our greenhouse gas emissions. Once animal products are grown and have been processed, then there's also, of course, agricultural transportation associated with getting those products to us, right? Just like there would be with vegetable crops and fruit crops as well. Okay, so then the last bit of advice is to limit your waste in general, right? I mean, that does two things. Of course, if you are actually consuming all of the food that you buy, then none of it is going to be wasted. And so then all of the transportation efforts that went into getting your food to your table are going to be, well, they're going to be useful and valid. But here's the other thing is that the more food that you throw away, the more methane that it emits as well, right? If you've ever driven past a landfill, the stinky smell is methane, right? And so if we can limit how much food gets wasted, then we can also start limiting how much food, well, is decaying unnecessarily and emitting that methane, okay? So then aside from that, like that's what you can do as a person, but how can you influence others to do this, right? I mean, isn't that always the problem? Like we're like, well, I'm not the problem. Like everybody else isn't doing it. How do I get other people to do this? So of course, like if you start, incorporating all of these practices into your daily life, there's a lot of influencing that you can do in your community to get others to adopt the same practices, okay? But then, of course, you've got your circle and I've got my circle of people that we associate, right? So how can we influence a community, an entire city, an entire state to adopt these practices as well? Well, sometimes it just comes down to good old-fashioned governmental pressure, right? So this might look like, joining certain political groups in your community and pushing for these sorts of measures to not only be adopted, but also if people aren't adhering to these, to push for some sorts of incentives for them to, adopt these instead of whatever else they're doing. The types of consequences I'm hinting at here are either monetary fines or even jail time for the people involved that aren't adhering to these measures to reduce greenhouse gas emissions. Thanks for joining me in this lecture series, everybody. I know that it's been a pretty lengthy one, but it is one of the most important student learning objectives for this course to cover global warming and all of the fundamentals behind it. So thank you so much for hanging in there, and I look forward to discussing this with you further throughout the rest of the semester.